Hi everybody. So you guys, if you are an A-Day student, you have a substitute today. And so I wanted to take and go over what we are going to be doing in class. First of all, today's April 21st, and your learning target is that you should be able to describe the structure of matter, including atoms and how atoms are identified. So this is day 2 of our STAR prep. If you are a virtual student at home, you are watching this and you need to go type STAR prep number 2 in for your warm-up. If you are in class face-to-face, you don't have to do that warm-up. A few housekeeping details: make sure that if you failed the ecology test and you have a 1B under our last assignment, or our last day in Google Classroom, please take care of that ASAP. It has all the instructions there for you. It's due by 3:30 Monday afternoon. Okay, so let's look at what we're going to do. STAR Review Day 2, you're going to have 4 stations, just like last time that you were in class. You should be seated in your assigned seat. Right now, normal assigned seat, so the sub can take attendance. And then you will move to the group that you were working with last time. And I will know if you're in different groups, so please only go to those groups whenever the substitute tells you to. You're going to have 2 stations that go over the structure of atoms. You'll have 1 station that goes over protons and valence electrons, and then we need to do 1 other station back with our physics stuff about balanced and unbalanced forces. You'll have an exit ticket at the end of class today that's due by midnight, and it's going to be made up of 5 questions. And again, make sure you take care of test corrections. So let's do a quick review before we get started. When you get to the balanced and unbalanced force station, remember, balanced forces do not change the motion of the object. So if the object is going to keep doing what it's doing, if it was moving, then it's going to continue to keep moving at that same speed, in the same direction. If it's at rest, well, it's going to stay at rest and not move. Only unbalanced forces, calculated net forces that are not 0, are going to cause a change in motion. That means the object could speed up, it could slow down, it could turn, it could stop, it could start. Those are the things that unbalanced forces cause. The next thing, when we go over atoms, remember you're going to be using the periodic table. The big number at top is called the atomic number, and that identifies the number of protons that atom has. And we're studying neutral atoms, so protons are going to always equal electrons. This number here that's a decimal is the average atomic mass, but we're going to know that our atomic mass is equal to our protons plus neutrons, and you will always be given this as a whole number, not a decimal number, in any of the questions that you might encounter. So if you can remember ape man, ape stands for A for atomic number, P for protons, and E for electrons. They're all equal. So in boron, there are 5 protons because that's the atomic number, and so there's also 5 electrons. Man is going to help us remember how to figure out the number of neutrons. That's where we take the mass that's going to be given to you as a whole number, and you subtract the atomic number for A, which would have been 5, and that's going to give you N, which is 6 for neutrons. So that's a little acronym that can help you. Now, just to remember those atoms that we have, we know that we have a nucleus made up of both protons and neutrons, and that we have electrons circling in the electron cloud. Protons have that positive charge, electrons have a negative charge, and neutrons have a neutral charge. Remember, protons will always identify the atom. So all you have to do is count the number of protons, and that will tell us what atom we're dealing with. Electrons in the outer shell are called valence electrons, and that tells us how reactive the element will be. And we'll deal with that more when we go over the periodic table next time. Protons and neutrons are found in the nucleus of the atom, and remember, that's where all the mass is. The electrons are in the electron cloud, and remember, they go 2, 8, and 8. We've only learned the first 3 levels, and they are too tiny to add mass, so we're not going to add those to anything. So that's our quick review. So now we'll go ahead and break into our lab groups, and the sub will put 10 minutes on a timer, and we'll keep track, and after 10 minutes we will rotate clockwise in the room to complete 4 stations, and then you will complete your Google form independently. 4 stations, you're working collaboratively, your Google form is independent, and we'll place our lab sheets in the red basket when you're done. Thank you and have a good day.